another organization that has lunch meetings occasionally, and a couple months ago I got the bulletin for that organization. Said there was going to be a discussion about invasive species in the Great Lakes, and I thought, big deal. I almost didn't go. Well, after I heard Roy's presentation, it is a big deal. It affects millions of people and billions of dollars of commerce. So I'm looking forward to hearing again, and I'm sure you'll enjoy his speech. Roy grew up in Ohio. He went astray and went to the school up north for a while to get his bachelor's degree, and then he went to Oregon and got his doctorate degree at the University of Wisconsin. Most of the items of his, or a lot of his items are in the bulletin, so I won't go over them, but just point out one, that he served on the Canadian-U.S. Joint Great Lakes Fishery Commission and facilitated a fish management in the Great Lakes. He's a professor emeritus at Ohio State in the College of Evolution, Ecology, and Organismal, I knew I'd mess it up, Organismal Biology. Please welcome Dr. Roy Stein.
You talk about a big, fat, slow one over the plate. Thank you, Don, for your introduction. It is organismal rather than orgasmic. Okay. I do want to tell you a little bit of a story, though, and the story goes like this. We were a department that was formerly known as zoology, but clearly zoology wasn't a cool term, right? And so ultimately, like any good academic faculty, we probably talked about that for 2 years. Important things, 20 minutes. So we finally came up with this one, Evolution, Ecology, and Organismal Biology, EEOB. One of our strong faculty members in the department who was always creative, just as we were getting ready to vote on this particular name, and we thought we had the votes to make that happen because, God, we were talking about it. And she said, what we should name, no, seriously, I have another suggestion. It should be Ecology, Integrated Biology, Evolution, Invasives, blah, 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 blah. And we're all looking at her like, are you from another planet? We've been talking about this name forever, and not, yada, yada, yada. No, she said, really, think about it. Think about the acronym E-I-E-I-O. Somebody quickly pointed out that the College of Agriculture wouldn't let us have it. Okay, so I did go to Michigan. I can use the word. I can't remember who won the game this year between Ohio State and Michigan. And then Wisconsin. I was at Wisconsin for a while, too, and I can't remember what happened in that game either. But you have the opportunity to make it a triple run there next year. I think our first game, maybe the first game at Ohio State is Oregon State. Is that correct? It's somewhere in the schedule is Oregon State. Yeah, I went there too. So you can kick there too. Thank you very much. I'd like to thank Don Bauer for being so kind to me, and to Scott Brown, wherever you are. He's walking around, for arranging all of the details of my visit. I appreciate it very much, and I also appreciate the generous welcome that I've received from all the members that I've met. Today, I'm going to be talking about the Great Lakes, providing some insight into the role that a subset of exotic species, just a subset, have played over the years in modifying ecosystem structure. That means who's there, who are the players in the ecosystem. So modifying the structure, who's there, and the function, how they operate in that system, and mostly from a fish's point of view. Because I'm ADHD, I have to use a lavalier mic, and I'm going to walk away from this mic. But man, I have some friends who can, they can build all kinds of things out of nothing. And I want to be close to them when the apocalypse happens, because what can I do but be a university professor? And after the apocalypse, what good are they going to be, right? Okay, so we got, so about St. Clair, and I mentioned this to Don, St. Clair is not a Great Lake, but it's a pretty good lake. Okay, and of course we all know where Columbus is. Anyway, this is where Columbus is, and so we're just directly south of the western basin of Lake Erie. The introduction. Just a few slides on just a few facts about the Great Lakes. This is going to be my introduction, or my outline. So if during the course of events you drift off, you can always come back because I'll be having the outline and you'll be able to see where we are. Okay, the Great Lakes. 10% of the world's fresh water. 10%, that's a lot of the world's fresh water. 3% of the world's drinking water. Important for shipping. And shipping is going to be incredibly important during the course of this conversation because it's shipping that had a dramatic influence on who got in to the Great Lakes. Okay, and we'll talk more about that as time goes on. Recreational fishery. It's very impressive right now in Lake Michigan. And for those of you that have been up on Lake Erie of late, yellow perch, walleye, tremendous fisheries there, a good steelhead fishery over in the northeastern part of the state. It's really a going concern in terms of fisheries. And then finally, commercial fisheries. We have a commercial fishery in the state of Ohio for yellow perch. That's the only species. On the other side of the lake, the Canadians have a commercial fishery for walleye. And that's how we're able to buy walleye in the store if we want to have some and don't want to go out and catch it. Okay, so that's just my brief introduction of the Great Lakes. Now we're going to go and start talking about some of these exotic species that are in the Great Lakes. Sea lampreys. This is the business end of sea lamprey. I don't know how many people have seen this before, but they have a rasping tongue, a rasping set of teeth that can literally put the hole in the side of a fish. So what happens is that they glom onto a fish, suck all the blood out of it, and kill it. Or sometimes not. Sometimes they drop off, and you catch fish with wounds that are fresh or that are healed. Here's something else that I'm going to do throughout the whole talk. The whole talk I'm going to be talking about a chronology that starts in the late 1800s and goes to 2010 and later. Okay? And so you can come back to that as we step through these various exotic species. Let's talk about sea lampreys. Invasion, right around 1919 or so, coming into Lake Erie about that time. Lake Ontario already had sea lampreys because they're connected to the ocean without any barriers. And so consequently, the sea lampreys have been in there for a very long time. But when we built the Welland Canal, and we built the Welland Canal for shipping, right, so that we could ship stuff into the St. Lawrence River, or into Lake Ontario, into the St. Lawrence River, and out to the ocean, right? So it was the Welland Canal by which they got in. Now, they could have gotten in by the Erie Canal, which ran south, but the big barrier that we're getting around with the Welland Canal is, of course, Niagara Falls. So they were prevented from coming in there by Niagara Falls, and then the Welland Canal went around that. Lamprey feed on top predators in the system. These might be at this time lake trout, burbot, other species like that. Sea lampreys are stream spawners, and their larvae grow in streams for a period of time as filter feeders, and that will become important in just a minute. Okay, so we got our invasion, recognizing that this was a bad species for the Great Lakes. Trapping was initiated, and then barriers were actually put in place. Dams were put in place on spawning rivers to prevent those animals from coming upstream. So those were the two techniques we had available to us at that time. About that time, and this is what Don talked about, the Great Lakes Fishery Commission was established, which is a binational organization. It was established in 1955. As I said, it's a binational agreement. And its primary role is really to control sea lamprey, although it has some science and some fish management kinds of roles as well. So the way the program is put on the ground by the Great Lakes Fishery Commission is through the U.S. Fish and Wildlife Service, and in Canada, the Department of Fisheries and Oceans, so the two federal arms of these organizations. So the GLFC was established, and by 1962, we had lampricides. And again, it's hard for me to overemphasize the importance of the discovery of lampricides. Fish and Wildlife Service guys and DFO guys went through 6,000 chemicals, trying to find a chemical that would kill the larvae of the lamprey, but would not harm other species in the streams. And it was an onerous task, and it was an impressive result that they got out of that. Now, how do lampricides work? What's important here is to think about vulnerable life stages in an exotic species life. Luckily, sea lamprey have one vulnerable life stage, and that is while they are filter feeding in streams, and they spend somewhere between 4 and 7 years, depending on water temperature and productivity of that stream, growing up as filter feeders. And then what happens is that they transform, and they actually change their whole body shape, and they gain those teeth that we talked about, and spend just 1 year out in the lake feeding on prey out there. And they do a real number during this period of time. And then, of course, the adults come back and spawn in rivers again. It's this filter feeding larval life stage that makes this animal vulnerable to control, because it means that we only have to treat streams with lampricides, the ones we just discovered, those lampricides once every 4 years at maximum, and once every 7 years for streams that flow into Lake Superior, for example. So, lucky on that one. Here's an example of what this control program has done. This is the impact of lamprey going into Lake Superior and what they did to the lake trout population based on monitoring surveys. They destroyed it. Lampricides came along, and you can see the numbers of lampreys that we had when we started monitoring in a very serious way, 1958 or so, 56. Very high numbers of lampreys. And then the lampricide treatments, those stream treatments, crashed the lamprey population, which was way cool. And then the very nice thing, and everybody in the Great Lakes community is proud of this, the lake trout population came back in Lake Superior. And that's an impressive success story, I think. So by about the mid-1990s, lake trout were restored in Lake Superior, which is an impressive sort of thing. Now we're working on sort of an integrated pest management approach, much like the folks use against insects, an integrated pest management approach where we use other techniques. We have sterile males, we capture them in the field, bring them in, sterilize them, put them back in the field, and then take those females, with whom they spawn, out of the reproductive pool. And then we also have pheromones. Pheromones are chemicals by which animals communicate with one another. And sea lamprey has a couple, and we're in the process of trying to exploit those, drawing them to trapping, drawing them into a stream that might be poor for spawning success for these guys, that sort of thing. So that's all happening in the context of this sea lamprey program. And probably, just so you know, it probably costs us about $20 million a year to treat the streams of the Great Lakes for sea lampreys. Okay, the next thing is alewife, next animal coming in. And the vector is how it got in, the impact is sort of what they're doing, and the control is what we're talking about. So in this particular case, I'm going to put the sea lamprey up there as a chronology first, okay, and then below that, I'll put alewives because I want to draw a little bit of a conclusion between the two of them. They were discovered in Lake Ontario. They came in via the Welland Canal and then into the rest of the lakes through time, discovered in Lake Erie in 1933, and then all lakes by 1955 or so. So that's how that all played out. Alewives coming into the Great Lakes. Now, here's the interesting point that I want to make. What's so cool about this, and what is so interesting, and what fascinates me as an ecologist, is that what sea lamprey did is prepare the environment for alewives and allow alewives to come into the system. In other words, they took top predators in the system that would eat alewives, and they would and they reduced them down to very low levels. That allowed alewives to come in, colonize, reproduce, and be successful. So in some sense, it was the sea lamprey facilitating the invasion of alewives, because before the sea lamprey, there were sufficient predatory mouths out there to take care of any of those colonist alewives that are coming into the system. I think it's a really fascinating sort of interaction. Without predators, alewives really skyrocketed. They overexploited their food and space, and of course they outcompeted the native species that were also feeding on similar food items as the alewife. And then we also had something called summer die-offs. I was an undergraduate in Michigan when some of this was going on, and I can tell you that the people of Chicago, especially those that were, right along the Magnificent Mile, where we had beaches that looked like that. And not only could you not use the beaches, even if you didn't go to the beaches, you could smell the beaches, okay? So this put a tremendous amount of pressure on sort of fish management in general in the Great Lakes. And people said, we got to do something about these alewives. Okay, so the conclusion was, let's stock another exotic. Oh, that's a good idea. So we're going to take one from the West Coast. We're not going to go down the street and find one, right? We're going to take one from the West Coast and put it into this system. Now, we didn't stock animals that big. That's just a representative of an adult. But we raised them in hatcheries, stocked them out at that size, and how did they do? We stocked them purposefully. Of course, it was another exotic. And fish managers made the argument during this whole time that, look, if we make a mistake, and this is a bad thing for the ecosystem, we just have to turn off the spigot. Not so much, because soon after their introduction, actually it did take a while, probably 10 or 15 years, for reasons I don't know why, but they're now naturally reproducing. So they are now naturalized species in the Great Lakes. It generated a tremendous recreational fishery that now is worth probably about $4 billion a year. And the native species, now this is again, this is so intriguing. This is so very interesting. So we had all these alewives out there, right? Didn't I ask you guys to turn off your phones? Come on. So we had these, I forgot where I was now. Oh yeah. So we had these alewives out there that drove native species down to very low levels through competition. All right, competition for food, competition for space. Then, on top of those tremendous numbers of alewives, we put salmon. And salmon are voracious, and they can eat a lot of alewives, and they control the alewife population, by gosh. They drove it down to low levels. What did the native species do? Whitefish and chubs, a variety of other species. The native species started to come back. And so, how interesting is that? We have an exotic species, we put another exotic species in, and we get an ancillary benefit of the native species coming back in that particular system. How fascinating is that? So here we are with alewives in a chronology. The salmon stocking occurred. The alewives were indeed controlled. Shocking in some ways. Wow. The fishery is truly impressive. Salmon reproducing now. Now what we're worried about is the salmon overgrazing the alewives. So we got to back off on stocking, try to estimate the number of fish that are produced in the wild, and try to move on with regard to that. Now we move into the one that's familiar to all of you who have been in Lake Erie ever, or the zebra mussels. Here's our alewife chronology, and here's our zebra mussel chronology. They came in about 1988 or so to Lake Erie. They reached extremely high numbers, as most of you know. And really, there's no way to control them, right? Now, what has happened is that the population has gone up, and it's peaked, and now it's coming back down again, and it's going to sort of stabilize at a lower level than we saw historically, but it's still not the best thing for Lake Erie. We were concerned it would be a real issue, but it looks like it's settled down to be not so bad, and we've actually seen an increase in water clarity with regard to zebra mussels. Those of you that go up on Lake Erie, you know that you can see these windrows of shells that happen on occasion, but we don't see those anymore so much. High densities, that they clog water intake pipes. They've made a substantial increase in costs for water treatment plants, et cetera. They're damaging to other species. They've completely outcompeted the native mollusks, and they're no longer essentially in the Great Lakes. And there really are no realistic controls. I could spend a long time talking about some of the things people have talked about, but we are just simply not there yet. Now it takes us to the round goby. It's another species that came in via ballast water from across the Atlantic. And this guy came in, and they came in the same way that zebra mussels came in. And they're also not subject to any kind of control at all. But here's another one of those interesting ecological meltdowns is what's characterized in the literature, but the facilitation of one species by another. Look here. What's happened? Zebra mussel is facilitating the invasion of gobies. And in this case, instead of predators being controlled and allowing the prey to get in, we have generated a prey supply for zebra mussels that is infinite in the form of zebra mussels. So round gobies certainly got into the lakes before this, but now, post zebra mussels, they had a food supply that wouldn't quit. And that's what allowed, we think, the success of round gobies coming into the system. So they eat zebra mussels, they're aggressive, high densities, they get about that big. Anybody that's fished up there has probably caught them on occasion. And they also eat smallmouth bass eggs. And this is where the story gets interesting. In spring, you know about smallmouth bass, they spawn in spring. The males, in an interesting reversal of roles here, males guard the eggs for 6 weeks, keep the gobies out, but through time what's happening is that as the population has increased in general over the last 20 years or so, people are also beginning to target smallmouth bass while they're on their nests. So there's been that targeting increase. And of course, when males get removed, gobies go in there and just decimate the nest, and they can do this in about 20 minutes or so. We're talking about animals that are operating at a density of about 20 per square meter, or 20 per square yard if you want to think of it from that perspective. That's a lot of biomass eating those eggs. We had a PhD student who did just some very cool work on videotaping, taking males off artificially and putting males back, and doing a whole series of really cool experiments. I can't give you the data today, but I can tell you that these male smallmouth bass were incredible at being able to keep gobies off their nest. So, round goby impact 1, the conclusion is what we're going to do is we're going to have an open spring season on smallmouth bass, being able to be jerked off the nests. The division saw the research that my student did and concluded they needed to do something. And what's happened now is that we have a closed spring season on smallmouth bass. And it's a catch and release. If you do catch them in a bycatch, some people still target them, but if you can get them back over the side in 3 or 4 minutes, you don't lose very many eggs. Okay, the round goby impact 2 is fascinating as well from an ecological point of view, from my point of view. This is the old food web: phytoplankton, zooplankton, little crustaceans in the water, prey fish, smallmouth bass. The new food web looks like this: sediments and algae go into zebra mussels. Zebra mussels get eaten by round gobies, and then round gobies get eaten by smallmouth bass. And we've actually seen increases in growth rate of largemouth bass or smallmouth bass because round gobies are there. The big question for us was PCBs, carcinogenic, mercury, bad for us, lead, bad for us. Those things were all sequestered in the sediments at one time. But now what zebra mussels have done is that they've fed on those sediments and those essentially toxicants that are there and get picked up by, of course, zebra mussels, who then roll into smallmouth bass. So we have this new food web now that looks like this. This is where the PCBs and the bad stuff are. And we've had an enhanced movement, and this is based on another PhD who did some very cool work in this arena, enhance the movements of these toxicants to smallmouth bass, which we eat. And so this has now become a health issue. And so when you look at the regs or you look at the Department of Health and they say, only eat X number of meals, it's because of this. X number of meals per month. It's because of those toxicants. Okay, snakehead is next. There's some really cool stuff. I wish I could tell you about snakehead, but I can't. Don't have time, but I can show you. There's the business end of one. They're kind of a cross between a catfish and an eel. One of the most amazing things about these critters is that they're air breathers. And what that means is that if they're in bodies of water that are small, like in small ponds along the East Coast,
They can actually, if one pond becomes sort of uninhabitable or over populated, they can actually squirm out of the water and squirm over to the next pond. So, can you imagine? Oh, I'm hunting rabbits today, and what's this? That must be pretty incredible. Okay, they're pretty voracious predators. They got in by the aquarium trade. People then, they get too big for their aquarium, so they put them out in the real world. And we've captured one in Chicago Harbor that was dead. And all we can say is, we hope we don't get them. There's no control that we have for those guys at this point. Now, one that you've all heard about, we're seeing in the news, Asian carp. Okay, there's 3 species. Excuse me. There's 3 species involved. Here's Asian carp. They've been imported for food, and there are some Asian cultures who believe, and they need to be alive when they're sold. We were in Shanghai not long ago, a few years ago, and we actually got to pick our big head carp out of an aquarium. Kind of like you pick a lobster, Pick that, we'll have that carp. And it was served, and it was delicious, I must say. But they were imported for food. And the folks the culture that takes these fish alive also have a tradition of releasing one to the wild so that consequently it will reproduce and continue to provide a food supply. It's not the best thing for our ecosystems in the Great Lakes. The other piece is escape from aquaculture. Arkansas Fish and Game, well, no, let's go back. Arkansas aquaculturists, those folks that raise fish for profit, such as catfish, had trouble with mollusks, which served as an intermediate host for a parasite. And they wanted to get rid of the mollusks, so they decided on their own to bring these 3 species in because they couldn't tell them apart when they were small, and put them into ponds, which is fine and would have been fine, except there's floods. There's floods. And so when the floods came in the Mississippi drainage, those 3 species got then into our system, known as the Mississippi River. We have captured 1 fish, and there have been intensive sampling that's been going on around 2002 or so. Asian carp. They don't all get this big, but by God, some of them get this big. They spawn multiple times annually, so they can really reach an environment and get really invade it quickly. High fecundity, more than 1 million eggs per female, regardless of species. They grow rapidly, obviously. What black carp eat, and this is the species supposedly that was introduced in Arkansas, eat mollusks and crustaceans. Silverhead and bighead, however, eat zooplankton and phytoplankton. Now this is incredibly important. These guys are feeding on phytoplankton in the water column. This is part, here's the water column. Phytoplankton is here, small unicellular algae. And then what eats the algae is typically zooplankton. And zooplankton are a millimeter or so in size. Every fish species starts out its life as a larvae about 5 to 10 millimeters or half an inch or so. Okay? They are forced, because of their gape size, to consume those zooplankton. If these guys get into the Great Lakes, it'll be ugly, because they'd be competing with the early stages of every, not just game fish, not just our darters, not just our groups of fishes that we're familiar with but maybe we don't catch or exploit. They'll be causing year-class failures in a number of species if they're as good as they say they are. They are now, because of that release from the Arkansas fish ponds, extremely abundant, and you can see it there, for reasons that I don't know that we know. Maybe somebody knows, but for reasons that I don't know. When an outboard motor goes over a dense population of these guys, they all come out of the water. they jump, like they're jumping right there. It's astonishing to see it. I mean, it's hard to imagine. In some systems in the Mississippi, 90% of the biomass are these species. And sometimes you have to protect yourself. And there are several folks who work for Fish and Wildlife Service, broken noses and injury to their heads and stuff. I mean, in some sense, it's funny, but it's really scary. So, why would we worry about them being in Mississippi? That's the Mississippi drainage. We're in the Great Lakes drainage, right? Well, what we've done then to aid the shipping industry is to connect the Mississippi drainage with the Great Lakes drainage. So we could run a boat filled with stuff from the Mississippi drainage, from the Gulf of Mexico, to the Mississippi drainage, to Lake Michigan, and ultimately out to the Atlantic Ocean if we wanted to go that way. And that happens at Romeoville, Illinois, right there where that little red circle is. We built something called, we've gotten one fish in Lake Erie so far, these Asian carp. Scares me. Okay, so what we've done then is build a dispersal barrier. We're going to prevent them from going up the Chicago Sanitary and Ship Canal. And it wasn't just for shipping, by the way, although that's what I emphasized. It is also a way in which Chicago gets rid of its wastes. It didn't want to put them out into Lake Michigan, southern Lake Michigan, because they like the lake. But Mississippi River, oh good, that goes downstream and away from us. So we have the Chicago Sanitary and Ship Canal. And what the Army Corps has done is build an electric barrier, a very big electric barrier. In fact, there are two. So there's some redundancy. And you can see how large it is there in the diagram. No mooring. Remember when your mom said, don't be fooling around with a hairdryer next to the bathtub? Well, this is exactly that, right? Exactly that. So that's where we are right now. I don't want you to think that the lakes are going down the tubes, because I have to tell you, and I've been talking to some fishermen in the audience as we were in your group, they know this already. The next 4 or 5 years of walleye fishing in Lake Erie is going to be the absolute best it has ever been. If anybody remembers the late 80s, 86, 87, 88, 89, when charter boats would come in would go out, would come in with a limit, and then take another group out and come in with a limit. They would do that 3 times a day. So that's coming again. And it's because we've had great year classes of walleye. And yellow perch are doing pretty well too. So what's the prognosis in the big scheme of things? Sea lamprey, I put it red because we're controlling sea lamprey right now, holding it down to 10% of its historical abundance. It costs some money to do that, you know, $20, $25 million a year, but we're able to do it, and that's because of its life history. So I think we're in good shape with sea lamprey. It'd be nice if we could get rid of them at some point, and maybe that'll happen, but it ain't happening yet. Alewives, it's yellow because we are in, we are in control, okay? By stocking salmon on top of alewives, we've kept that population down. The only concern, as I mentioned earlier, is that in Lake Huron, salmon, because of the stocking rates that were in Lake Huron, have essentially eliminated alewives from Lake Huron. There is a concern that's going to happen a second time in Lake Michigan. It'll be intriguing to see how that all plays out. It's a very interesting and complicated problem. Zebra mussels, green light, they're here, we got them. Round gobies, they're here, we got them. There are some positive effects as well as negative effects. We talked about increasing smallmouth bass growth rates, which is kind of cool, but they're here. On the horizon, this is a commercial commercial words from your sponsor. The electric barrier that the Army Corps put in with great fanfare will not work. It might work this year, it might work next year, it might work for 5 years, it might work for 10 years. The only thing that will work in the Chicago Sanitary and Ship Canal is dirt. We need to fill that, we shouldn't have these two watersheds connected. We should fill it with dirt, put in a rail passage so that boats then unload, put it on a rail car, run it whatever distance they have to, and get it into the Mississippi drainage. These costs, and again, this is commercial, right? These costs have been externalized to us, the public. And it's just not right. Okay, so Asian carp, we don't know. You know, it's still yellow, we're still keeping them out. Let's hope that the barrier works. And snakeheads, same thing. We hope that the education gets out there, that people don't take fish from their aquarium and take them down the street and drop them into a stream that runs into the Great Lakes. So that's where we are. I think the suite of interactions that have occurred in the Great Lakes are absolutely fascinating. We continue to watch how all these things play out. We've got excellent people doing research in this arena, and we'll make progress through time and perhaps be able to mediate some of the effects of these exotics. But for the time being, this is where we are in the Great Lakes. Thank you.
Thank you very much, Roy, for a fascinating talk. All right, one question. Who wants it?
Sir.
Is there the removal of the low wellhead dams, for example, on the mighty Olentangy, does that have anything to do with controlling invasive species?
Maybe not so much on the Olentangy, but there are, if you look at Michigan, if you look at Ohio, I don't know if you all know about the Ballville Dam, but the Ballville Dam is coming out on the Sandusky River to allow spawning of walleye upstream. That will increase the cost of treating for sea lampreys because that will be more stream miles they will have to treat. We have been in the unusual position, and when I say we, I say the Great Lakes Fishery Commission, been in an unusual position of trying to defend dams, which we all know is, you know, people are taking dams out everywhere because that's a good thing for the stream corridor, for the fishes that live there. But in our case, when they do serve as a barrier, and let's say you've got, I don't know, 250 miles of watershed stream, that's a bear to treat. So the community is working very hard in terms of trying to find ways that we can pass fish around these barriers and prevent sea lampreys from going upstream because it's a cheap way to treat.
Thank you very much. And I, like Don, am very glad that I didn't skip the meeting and got to hear the speech today. I think each of you out there knows a Rotarian who isn't here today. Why don't you send a message to them, let them know, beyond missing their companionship, they missed out on a great meeting today, and we hope they could come to the next one. Callaway. Thank you. So, and they'll have a chance in 2 weeks to come back for our December 18th meeting. Lots on board there, the spouses luncheon, elections for our board of directors, and another good time. So please, we'll see you then, if not on Sunday at the concert. Have a good one.